So let's continue our discussion on compound interest. So we have already learned that compound interest could be done once a year, okay, compounded annually. It could be done multiple times within the year as well. So that is compounded several times in a year, okay? Now we also have what we call as continuous compounding. So some banks use continuous compounding where compounding periods increase infinitely, okay? So this is like the third formula for compound interest that you will be seeing. So remember, when we are talking about compounding several times in a year, this is the one with the R over N, okay? The N is included. N is the number of times it was compounded during the year. When it is compounding, so continuously or continuous compounding, the formula now is A is equal to the principal times the number E, okay? E in math is like, pi is 3.14. E has a numeric value. And P and E, when you multiply, E will be raised to the exponent R and T. Okay? So how would you know if you need to do continuous compounding? You gotta read the problem very well. Okay? It will say it in the problem what kind of compounding it needs to be done. All right? So let's have this example. You decide to invest $8,000. So invest, okay, this is our P. For 6 years, we know that this is our time. And you have a choice between two accounts, okay? So we are going to be doing some comparison. So let's split our screen here, okay? The first, okay, account number 1 has a 7% per year, so that's the R, and it is compounded monthly, okay? So account A, is going to be compounded monthly, so we know that we will be using A is equal to P times 1 plus R over N raised to NT. That's our A. Now, the second uses 6.85 per year, so this is the rate, and it is compounded continuously. So we mean that for B, second amount, it's going to be the P times the E raised to RT. Okay? So which is the better investment? How do you decide which is the better investment? Well, the amount that will get you more interest in a shorter period of time. Okay? All right. You have like the one that will generate you more money after that particular number of years. They are both going to be invested for 6 years. So which of these two computations will generate more money after 6 years? Okay? So let's work with investment A. Replacing our values, this will be 8,000. 1 plus our R is 7%, so 0.07 over, because it's compounded monthly, the N is 12, all right? And then N is 12, and the number of years is 6. So that's how our formula would look like. And once you type this into your calculator, you will get around, let's see here, this is going to give us $12,160.84. Okay? Not bad. Almost like earned $4,000 after 6 years. Okay? Now, let's take a look at second investment. Now, this time, it has a smaller percent, but it is compounded continuously. So let's put that in. So 8,000 is still our P. E, okay, and then R is the rate, which is 0.0685 multiplied by the number of years, which is 6, okay? So once you type this into your calculator, your future amount is gonna be at around 12,000. Not bad, all right? $66.60. Okay? So between the two kinds of investments, which compound interest is the better option? Now, as you can see, in 6 years, this one, the compounded monthly, can generate a better amount after 6 years. Okay, so that is how you can compare investments, especially with the different types of compound interest available. All right. Okay, so this time, this is the formula for finding the present value, the amount that is being borrowed or invested or deposited. Okay, now this is not a weird or new formula. This is the same from the original one. A is equal to P times 1 plus R over N and T. Okay, we are just solving for P. So how do we do that? P times this whole thing. So we divide by 1 plus R over N and T over here. So as you can see, it's going to be done over here on A. So that is just that, all right? We did not create any new formula just to get P. We just rearrange so that P is isolated this time, okay? So let's have our example. How much money should be deposited into an account that earns 6%? Our rate, okay? Compounded monthly. So monthly, the N is 12. So that it will accumulate 20,000 in 5 years. So 5 years is the T, 20,000 is the future value, okay? We need to know what is the amount to be deposited. So if we use the formula, P is equal to the A over 1 plus R over N raised to NT, okay? We replace all of these variables here. So 20,000 is on the numerator all over 1 plus R is 6%, so 0.06 over N is monthly, so that's 12. 12 times for how many years? 5 years. So make sure you enter this as it is in your calculator. And approximately the principal, the deposit that needs to be made is roughly around, okay? Always round up your number to 2 decimal places because we're talking about money. $14,827.44. So that's what you need to deposit so that after 5 years, you're going to have 20,000 in your account. All right. Moving on. There's also what we call as the effective annual yield or the effective rate. So simply, this is just like the simple interest rate that produces the same amount of money at the end of 1 year if the original account is subject to compound interest. Okay, so pretty much the rate is that. So here, what we do is we find the future value. So find the future value using the compounded interest formula. And then once we have that, we find the rate using the simple interest formula. Okay, simple interest formula. That's how this is gonna work. Okay, so let's have this example. So you deposit 4,000, that's our P, in an account that pays 8%, that's our R, compounded monthly, N is equal to 12. What is the future value in 1 year? Okay, 1 year. So first things first, we solve the future value. So A is equal to P times 1 plus R over N raised to NT. We replace those values, 4,000 times 1 plus the R, which is 8%, 0.08 over 12 because it's compounded monthly, 12 times the number of years, 1 year, okay? So putting this into your calculator, letting your calculator do its magic, the future value is going to be around $4,332, okay? Let's have it like a solid amount. That's the future value, okay? So now, how do we find the effective annual yield, okay? So we need to have the rate using finding the rate using the simple interest formula, okay? So that's what we will be using. Now, if you would remember, what's the simple interest formula? A is equal to P times 1 plus rate times time, okay? That's how it will be, okay? So, let's replace the values. We are looking for the R, okay? We're looking for the R. So, A, the future value is this one, okay? So, 4332 is equal to, the P is still the same. It was a $4,000 times 1 plus the T. How many is the T? That's a 1, okay? So, 1 times R, it's just going to be R, all right? So, how do we solve for R? Algebraically, we distribute first. So, this is going to be 4332. Oops, sorry, 4332. 4,000 times 1 is equal to 4,000 plus 4,000 times R, which is 4,000 R. Solving for R, we subtract 4,000 on both sides. Minus 4,000, okay? So, we now have 332 is equal to 4,000 R. How do we solve for R? We divide by the number attached to it. So that's 4,000. Oops, sorry. My bad. 4,000. Divide 332 by 4,000. And you will get an R that is going to be equal to what? So using your calculator, you'll get an R which is 0.083. Now remember, this is a decimal value. So changing it to percent, it will be 8.3%. So this is the effective annual yield. So pretty much that's everything for compound interest and also everything for chapter 7. Thank you.